Okay, we're going to start the second half of lesson 5.7 by reviewing what we learned in the first half. So we learned how to guess what the zeros are for a polynomial function. It's important to remember that you shouldn't guess unless you have to. Looking at number 1, the ratio of the coefficients is the same. So we know factoring by grouping will work. So from the first group, I can take out x squared. Leaving behind x plus 1. From the second group, I can take out a positive 9. We're finding the 0, so that means equal it to 0 and solve. X squared plus 9 goes together. X plus 1 has its own parentheses. It is not squared because it's addition. So by the zero product property, either this equals 0 or this one does. So over here we would get negative 1 as the 0. And we would also get plus or minus 3i. So always check for a GCF. This one doesn't have one. Then check if you can factor. Let's look at the ratios. 1 to negative 3, 4 to negative 12. This set multiplied by 4 equals that set, so factoring by grouping will work. We can take out x squared from the first group, leaving x minus 3 in the parentheses. We can take out a positive 4 from the second group, also leaving x minus 3. We're finding the zeros, so equaling it to 0 and solving. Zero product property says one of these parentheses has to equal 0. So the degree was 3, and we got 3 solutions again. Okay. On number 3, doesn't look like factoring by grouping will work. We have a 1 to negative 10 ratio. This is not a 1 to negative 10 ratio. Maybe if the 34 was replaced with a positive 4. Alright, so we learned that we're going to have to guess what the root is. Alright, so reviewing what we learned in the last lesson, we could actually review what we learned in the last 2 lessons. So, counting the sign changes, we know that the number of positive roots is going to be, there are 3 sign changes, so there's going to be 3 or 1. The number of negative roots, so this one will change, this one will stay the same, this one will change, this one will stay the same. There will be no negative roots, so we don't want to bother guessing any negatives. And then we could also make the list of possible rational roots. So factors of 40 divided by factors of 1. We have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, And 6 and 7 don't go in, and now I'm just going backwards. 5 times 8, 4 times 10, 2 times 20, and 1 times 40. Alright, and I wrote plus or minus out of habit. We already determined that there are no negative roots. So let's guess something positive. So I'm going to guess 4. Bring down the 1. 1 times 4 is 4. Negative 10 plus 4 is negative 6. Negative 6 times 4 is negative 24. 34 minus 24 is 10. 4 times 10 is 40. So since the remainder is 0, positive 4 is one of the roots. And so now we look at the depressed polynomial. The depressed polynomial is a squared minus 6a plus 10. That does not look factorable. 1 and 10 cannot make 6. 2 and 5 cannot make 6. So let's try completing the square. So to make that a perfect square trinomial, I need to add 9 to both sides. A minus 3 squared equals negative 1. So a minus 3 equals plus or minus I. So we get that a equals 3 plus or minus I. And don't forget the solution we found earlier, 4. So now we have our 3 solutions. For number 4, it doesn't look like factoring by grouping will work. This number multiplied by 3 is that number. But if we multiply 1 by 3, we do not get 11, so the ratios don't match up. So let's check the sign changes first. Positive, negative, positive, negative. So that is 3 changes. So we're going to have 3 or 1 positive roots. Plugging in negative x, this would be negative. This one would stay negative. This one would be negative. This one would be negative. So again, we don't have any negative roots, so we're not going to guess any negative numbers. And so this time I'm not going to write plus or minus for my list because we already know that no negatives will work. So it's either going to be 1, 3, 5, or 15. So those are the possible rational roots. We know that 3 of them could work, or maybe only 1 of them works, and then the other 2 are imaginary. So let's set up our synthetic division. So before we just plug in 1 is pretty easy to plug in mentally. So if I plug in 1 cubed is 1. So it would be 1 minus 5 is negative 4. Negative 4 plus 11 is positive 7, and then minus 15, that does not make 0. So positive 1 is not going to work. What about 3? 3 would make 27. Minus 45 is negative 18. Negative 18 plus 33. Yeah, that looks like it works. So let's try 3. Bring down the 1. 3 times 1 is 3. Negative 5 plus 3 is negative 2. 3 times negative 2 is negative 6. 11 minus 6 is 5. 5 times 3 makes 15. No remainder, so it works. And again, it looks like the depressed polynomial is not factorable. X squared minus 2x plus 5. 5 and 1 cannot make negative 2. So because the b value is even, let's try completing the square again. The b value is negative 2. Divide that by 2, you get negative 1. Squaring negative 1, you get plus 1. Add that to both sides. If we factor, we get x minus 1 squared equals negative 4. So x minus 1 equals plus or minus 2i. Our final answer is 1 plus or minus 2i. And then earlier we found 3. Okay, for the next problem, now we're going backwards. They give you the roots or the zeros, and you're going to write the polynomial function. So in order to get a 0 of negative 1, that comes from the binomial x plus 1. So think about what value of x would make that set of parentheses equal 0. And that would be negative 1. So you just do the opposite. So if the next one is positive 4, we write x minus 4. In the last lesson, we were reminded that imaginary roots always come in pairs. So if they tell us 3i is a root, then the conjugate, which is negative 3i, also has to be a root because they never travel alone. Right, so I need x minus 3i and x plus 3i as well. Right, so I'm going to multiply the first two together. If I FOIL, I get x squared. And the outside is negative 4x, and the inside is plus x. So I'm just going to combine that in my head now. Minus 3x minus 4. Right, when you multiply conjugates, you don't have to FOIL. You can just do the front together and the back together. The back makes negative 9i squared. But if I squared is negative 1, negative 9i squared is plus 9. All right, so I'm going to take a break here to show you a shortcut for the complex roots. This shortcut actually works with all roots. So if you take any two roots, if you find the sum, so the sum of those two is 0. And if you find the product, 3i times negative 3i is negative 9i squared, or positive 9. So there's a shortcut you could use. With any two roots, the polynomial is going to become x squared minus the sum times x plus the product. So look at this binomial here. We have x squared minus 0x plus 9, the product. So that shortcut will be really helpful on the next problem. All right, so for now, we're going to continue. I need to multiply all of these by x squared. So I get x to the 4th minus 3x to the 3rd minus 4x squared. And now I need to multiply all of them by 9. So I get plus 9x squared minus 27x minus 36. Combining these together, and we want this to be a function, so I'm going to write f of x equals x to the fourth minus 3x cubed plus 5x squared minus 27x minus 36. Okay, so now the shortcut for number 6 is going to save us a lot of time. So we know that, I'm going to write the f of x right now. We know that if 2 is a root, then we have the binomial x minus 2. And if 5 is a root, the binomial is x minus 5. We also know that if 1 plus I is a root, so is its conjugate 1 minus I. All right, so if I do the shortcut on those, the sum of those two is 2. 1 plus I plus 1 minus I. The i's cancel out, so the sum is 2. The product would be 1 minus I squared. 1 minus I squared is the same as 1 plus 1, or 2. So using the shortcut, it's going to be x squared minus sum x plus product. Okay, and now we have to multiply it all out. So I can actually do the shortcut on these two as well. X squared minus the sum of 2 and 5 is 7, minus the sum times x plus the product. So now we're going to multiply the two trinomials together. So if I'm doing a trinomial times a trinomial, that'll give me 9 terms, but some of them will be able to be combined. So first I'm going to do x squared times all of these. So x squared times all of those, we get x to the fourth minus 2x to the third plus 2x squared. Now I'm going to multiply negative 7x times the circled part. So that'll be negative 7x to the third plus 14x squared minus 14x. Now I have to multiply 10 to the circled part. So that'll be plus 10x squared minus 20x plus 20. So combining all these together, we get f of x equals x to the fourth minus 9x cubed plus 2 plus 14 is 16 plus another 10 is 26x squared minus 34x plus 20. In the last problem, we have a wooden box. We want to reduce the volume so that it becomes 105 cubic inches. The box was 10 by 8 by 6. We're going to reduce each dimension by the same amount. Okay, so the first dimension, the 10, is going to get reduced by some number. The 8 is going to get reduced by x also. And the 6 is also going to get reduced by that. Multiplying these three dimensions together, we want the volume to become 105. All right, so I'm going to multiply the 10 minus x last because it's easy to multiply by 10. So foiling this one, 8 times 6 is 48. Negative 8x and negative 6x make negative 14x. And we have a positive x squared. All right, distributing 10 to the trinomial, we get 480 minus 140x plus 10x squared. And now distributing the negative x to the trinomial, we get negative 48x plus 14x squared minus x to the third. Okay, so rearranging it and combining like terms, I get negative x cubed plus 24x squared minus 188x plus 480 equals 105. So we want it to equal 0 in order to find the zeros. So I'm going to move the 105 to the left side. 480 minus 105 becomes 375. Factoring by grouping will not work, so it looks like we have to guess. All right, so because this is a word problem, we probably want to eliminate any negative answers. So we're going to decrease each dimension by some positive number. If you decrease something by a negative number, it actually gets bigger. So we want to try positive values of x only. And we know that whatever number we choose should be a factor of 375. So 1 doesn't look like it'll work. Negative 1. Yeah, if you just plug in negative 1, you can look at it and tell that it's not going to work. So let's try, well, 2 doesn't go in, so let's try 3. 21 times 3 is 63. 63 minus 188 is negative 125. 3 times negative 125 is negative 375. So we have no remainder. So we found that 3 works. Let's just make sure nothing else works. The depressed polynomial there's our depressed polynomial. We can multiply everything by negative 1. That doesn't look factorable. So before I solve that, I'm going to check what the discriminant is. So remember the discriminant is b squared minus 4ac. So I'm just going to do that part. B squared would be 441. Negative 21 times negative 21 is 441 minus 4 times 1 times 125. 4 times 125 is 500. So I can tell that the discriminant will be negative. If the discriminant is negative, then you have 2 irrational roots. Two imaginary roots or 2 complex roots. So because we have two complex roots, those don't count for the answer to this word problem, so the only answer is the 3. So going back to the question asked how much should we take from each side? So the answer is 3 inches. So again, we knew there were going to be 3 answers, but I used the discriminant to figure out that the other 2 were going to be complex roots, so those don't count. So our only answer is 3 inches. All right, that's all for this lesson.